Again, I'm so sorry about the noise outside. I just came inside and trying to continue lecture. However, I guess I missed the very last part of section 7. I just copied it here so we can just again talk about this. But the bottom line is a 3 years old can execute two if-then statement one at a time. However, this is not the case for 2 years old because they can just only do one if-then statement at a time. The if-then statement for 3 years old shouldn't be that much complex. They should be simple, based on rule-based theory. The reason for that is short-term memory's capacity. Regardless of being 2 years old or 3 years old, the memory's capacity is not that much developed. So basically, they cannot memorize everything from the environment. They cannot rely a lot on their experiences because they can forget. Like they can literally forget whatever you just asked them at a moment. So you have to consider that. And the main difference between a 3 years old and a 2 years old is, again, short-term memory capacity. Because like for 3 years old, it is just more developed, which is not the case in 2 years old. So just keep that in your mind. Let's mix them up. If you would go back to the previous lectures or just take a quick look at your final project, you can understand that I asked you a lot of questions about conservation task, option number 2. So you can just actually think about rule-based problem solving and try to just mix them up with conservation task. And just if you are actually choosing this option for your final project, you can just understand at what point the child would give up, if that makes sense. For example, we cannot expect like 6 years old to just execute several if-then statements. And if they would do that, we can just mention that in our conclusion part, hey, this child was just very good, very smart. They could do like several if-then statements. They can just answer whatever questions that I asked, because if you would just go over the questions, you can see how complicated they might be at some point. So I want all of this kind of reasoning in your project write-up. So read rule-based problem solving from your book very carefully, because first of all, it can help you to just pass the quiz. It can help you to just understand the material better and just get ready more for your last test. And lastly, it can help you a lot for your final project. So go for that. So far, we talked about rule-based problem solving. Now I'm going to talk a bit about reasoning by analogy, which is like, for example, you have a new experience, a new problem in front of you, and you are trying to just rely on your past experiences, like your past knowledge, to just address the new problem, if that makes sense. I will give you an example. For example, you just passed cognitive psychology course like last semester. Whatever you're going to apply from that course in developmental psychology, this new course, it's going to be reasoning by analogy, because basically you have some past experiences and you're going to apply those past knowledge in your current problem. So here is a video. It is basically about object permanency. Watch that carefully. It is important. It can help you a lot to just understand materials better. I would suggest you to just go over whatever experiments that I'm just asking you to watch, or I'm just asking you, hey, this is important, or we have it in the book, because they are so important. They are just like wherever you go in psychology, you're going to talk about object permanency, you're going to talk about Sally Ann task. We have that, I guess, in the last section. Or you're going to, for example, talk about if-then problem solving. So read that. Take the notes because they are also important for your test. There are going to be questions about each experiment in your test. So let's talk about how memory can be related to problem solving. They are just interacting with each other. For example, a good memory can help you to just solve the problem better. And your past experience in your past problem solving can actually enhance your memory capacity. So they are so connected because if you would just have new experiences, you would use your memory more and more. So the capacity going to be more, hopefully, if that makes sense, because of the brain plasticity in younger age. So they are just interacting with each other. They are just so important and connected. So this actually leads to the idea of Rabi cases theory. It is also very important. I guess they're gonna be like 2 or 3 pages in your book about this. But the main point about this theory is just emphasizing on memory rule. It is very similar to Piaget. It also has like different stages, but here, like the major part is memory and memory's capacity. So here you can see two major parts in Robbie Case's theory, which is like based on the memory rule. For example, the number one is operating space. Number two is short-term storage capacity. So what is operating space? It is like necessary resources to carry out cognitive operation. What does it mean? For example, a child should have an idea about numbers to count apples on the table. For example, if they wouldn't know anything about numbers, if they wouldn't know 1, 2, 3, how they can just count apples. Um, Rule number two is short-term storage space. Robbie Case actually believed that there should be resources necessary to store different information. For example, children, they have to just have that kind of capacity to remember the stuff in their brain. And this might not happen because they are so young and they don't have a lot of short-term storage in their cognitive area. So you have to just understand these two rules. There are going to be some examples in your book. There are going to be some comparison between Case and Piaget. Read them. They are so important. I actually wrote down some of them here. For example, one of them that is very important is this one. As children grow up, their memory capacity expands and they can actually process the information faster and faster. But it doesn't necessarily mean like because they are getting older and they are growing up, this kind of process gonna be just faster every time. For example, there's gonna be a limit for that. Right before puberty, the speed gonna be lower, if that makes sense. For example, let's say they're gonna actually increase the rate by age 6, 7, 8, but suddenly by age 9 and 10, it's not gonna be that much difference comparing to the past. Like that speed gonna just stop at some point. So yes, we have it here. We know that the speed will be constant at a certain age. It is important. Another point that is very important in Case is children develop cognitively based on repetition of the task. So basically, if they would actually try to repeat their stuff more and more, try to memorize their stuff, they can get better in understanding a task and doing problem solving for a new task.